This is our science honors project, and we're going to be doing 3 experiments that have to do with chemical reactions.
So our first one involves an egg in vinegar. So this is the egg as it started out. We put it in a jar of vinegar for about like 30 hours. Yeah, like 38. Okay. And this is the result. It dissolved the eggshell and left this, it was leaking, okay, and left this small egg layer. So it can like bounce.
It left it layer just inside of the egg, and it also...
That's so cool!
And see, it can bounce when you drop it from a lower... This is the
skin of
that it left. It bounces when you drop it from a very low point, but as you get higher,
is leaking, so
as you get higher, then it goes away.
Okay, so the explanation for this project, that was really cool. I have photography of it before, and I'll put that in the video. Is when you put an egg in vinegar, the shell dissolves, and it's because the vinegar contains acid, which breaks apart the solid calcium carbonate crystals that make up the eggshell into their calcium and carbonate parts. Calcium ions float free. Calcium ions are atoms that are missing an electron, while the carbonate goes to the carbon dioxide, the bubbles you see in the videos that we will show. And that's it. Bye. You can see it cracking all over the place. It's cool.
What?
As you can see, the whole shell's off.
I want to see this.
This is after 24 hours. That, and then here's the lid. Looks like a couch.
Hey, this is our second experiment, and it's called elephant toothpaste. Some of you have probably seen it. So what we have here is dish soap, yeast, hydrogen peroxide, and food coloring, and then an empty bottle, which we'll put them all in. And it might not be as spectacular as some of the things you might have seen because we only have 3% hydrogen peroxide because 30% is really dangerous. So yeah.
And so, before I do this, let me just explain this. So the hydrogen peroxide takes out all the oxygen in it, which causes it to like kind of explode. But as she said, it won't be as cool as the videos you're gonna see because we just couldn't get our hands on it. We tried, trust me, we tried, but we couldn't do it. Okay, so I'm just gonna start with this. And then I think food dye goes next, so.
Alright.
Cool, okay. Put a lot in there. Okay, I think that's good. And then I'm gonna put in a dish soap. Go ahead. No, don't stir it, Lucas. Put in a little bit more. There we go. And then we're gonna put in some yeast, and hopefully this works. I really hope this works.
I back up.
Is it working?
It's
kind of, yeah. Go. Okay, it's kind of working. It's going. It's coming.
Stir it a little bit more.
It's coming.
Alright, that's good.
Do you think maybe we need more carbon dioxide? No. Okay, it's going. It's rising. It's rising. It's going.
I think we should put more of everything. I think we should start over and put more of everything.
Well, we don't have enough. Here, go get the hydrogen
Yeah, we have enough
peroxide.
hydrogen peroxide.
We will be right back momentarily.
With a more spectacular explosion.
Expansion.
I think we should do the hydrogen peroxide last.
No, we're supposed to do the yeast last.
Back.
With some more stuff because that didn't wasn't enough. Just pour like up to the 4 ounces. I mean, yeah. There. That's probably good. And then we're gonna pour some more yeast. Go. It's going! See, it's going. Yay! Yay!
So it would probably happen a lot faster. Maybe we should do like the whole like rising thing in time lapse.
That would be so cool. Okay.
Yeah, but
And then we're gonna just do this in time lapse quickly. This is the final result, and it's all over the place, but that's okay. It's like some orange stripes here.
it is continuing to come out.
So it's still coming, which is awesome.
Ready?
Yeah. Yay! So it's really cool, and I'm glad we did the orange, because orange is awesome. Look at that.
Is it okay if I FaceTime Hunter and show him?
And that's it.
There's
Sadie with our elephant toothpaste explanation.
Okay, so what happens is that hydrogen peroxide breaks down into oxygen and water. There's so much oxygen, so the rapid decomposition means that the oxygen's being forced out. And so as the peroxide breaks down, the soap also combines with the water from the breakdown and turns into foam. So the oxygen makes the soap bubbles move really quickly out of the opening. And at first it's just hydrogen peroxide and then the soap and the food coloring. And so there's nothing really happening, but then once you add the catalyst, which in this case is yeast, that's when it really causes the show to start.
And yeah. So we are back with our third experiment, and it is making a lava lamp. So we have, next one.
Yeah, so we have water on the bottom and then olive oil on the top, and because obviously density, and then we put in some food coloring, which we're waiting for it to drop, and this is gonna be what causes the bubbles, or no, what the bubbles are really made up of. So we're just waiting for those.
I think we can do it now, because I don't think there's a
And
time
then
there.
we didn't have Alka-Seltzer tablets, so we decided we would try and use this fizzy vitamin supplement instead and
It's tangerine flavor.
see if that would work.
Okay.
Okay, moment of truth.
Do we mix it in? No, okay. That's good. Oh, I think it's working. It's working! Yeah! Okay. So I'm gonna go. So here we go. Okay, so I'm gonna lift it a little bit. So as you can see, it's like making some bubbles, kind of.
And as we would wait for it, it would work better, and the bubbles will be colorful. Just, it takes a little bit more patience.
But we don't have that. So
Yeah,
look
so
at
we're
it.
just improvising.
Okay, that's it. We'll come back with an explanation.
Okay, so the explanation of the lava lamp. So the way that real lava lamps work is that the densities of liquids are much closer together than the vegetable oil and water that we use. So the denser liquid sinks to the bottom, but the light of the lava lamp heats it up until it expands and becomes less dense, which causes it to rise upwards. And the farther it gets from the light, it cools down, and so it becomes more dense until it sinks, and then the cycle starts all over. Because we don't use the light in our homemade lava lamp, we use the fizzy stuff,
C.
and it reacts with the water to produce the carbon dioxide gas bubbles, and so they stick to the water droplets, and then the water-gas combo is less dense than the oil, so they rise to the top of the flask. And then at the top, they pop and escape into the air, allowing the dense water to sink back to the bottom again. So the love lamps that are powered by heat are trickier to use and make, and they weren't quite as valid for this, so we used the simpler version.
Yeah, and that's it.
Yeah, and that's the end of our honors project on chemical reactions.
Plus explanations.